Hi everyone, today we're going to talk about properties of logarithms. Specifically, we're going to be expanding logarithms. So when you think about expanding, you should think about like making things a little bit bigger, making them a little bit longer, just in general. So to expand logarithms means to take something that's kind of condensed and just kind of draw it all out. So we've got three properties of logarithms today. And before we talk about these, I want to just review with you about how to switch between exponential form and logarithmic form. So in exponential form, you have a base, b, you raise it to a power p, and it equals a number n. If you are rewriting this in logarithmic form, you would say log base b of your number equals the power. So it's not base to the power equals number, it's log base b of the number equals the power. So we kind of go in this direction. Base b raised to the power equals the number. So if I gave you an exponential form of an equation that was 5 squared equals 25. We all know 5 squared equals 25, but if I were rewriting it in logarithmic form, I would say log base b, so the base is 5, so log base 5 of the number that it equals, so that would be 25, and it equals the power that you had to raise 5 to get 25, so that would be 2. A little trick is that if you have a 5 and a 2 together, like 5 squared, then the 5 and the 2 will not be together here. So if you've got these two together and then it's together again, that's not necessarily true. It gets a little bit more difficult whenever you have exponents instead of numbers that you know is an equation that's true. So if I had like r to the power of t equals w, and I needed to rewrite it in logarithmic form, I would say log base r of w equals the power t. Okay, so log base r of w equals t. R to the power of t equals w. The other thing is going from logarithmic form to exponential form. So if I have like log base b of x equals 7. Well, that means that if I were writing in exponential form, the base here is b. The power that I should raise it to is 7. And the number that it equals is a variable here, it's x. So just to help you remember how to go from exponential form to logarithmic form, when we talk about our properties of logarithms, we deal with variables b, m, and n. They're all positive numbers, there's no negative numbers, and then b cannot be equal to 1. So the base cannot be equal to 1. Why is that? Well, if you have any base and you raise it to any power, let's say we have 1 to the power of 4. What that means is 1 times itself 4 times. 1 times 1 times 1 times 1 is going to be 1. So if the base is 1, then you can never get any number other than 1. So that's why the base b cannot be equal to 1. We have 3 properties here. These 3 properties need to be memorized. So if you're a flashcard person, these 3 things need to be on flashcards. The product property, product means multiplication. So the product property occurs when you have log base b, or base something, of a product. So here, this is a product. You have m times n. And so if you're taking log base b of a product, you can rewrite this in expanded form. Log base b of m, this first piece of the product, and log base b of n, the second piece in the product, but you can add them together. So I want you to think about multiplication and addition are the operations that make things bigger. So if you multiply numbers together, if you add them together, you get bigger numbers in the end. So that's why they go together. Log base b of m times n can be expanded to be log base b of m plus log base b of n. Notice that the base, is the same throughout. So you never change that base. So I'm going to move to example 1, because example 1 deals with the product property. So it says expand each logarithmic expression using the properties of logarithms. So here on number 1, we're going to use product property, and I recognize that it's product property because we've got log base 7 of 5xy, and 5xy is 5 times x times y all together. This is multiplication. So number 1, we're going to use product property. So when I expand this, remember that the base remains the same throughout. And each of the pieces that you multiply get their own logarithmic term. You just add them together. So this becomes log base 7 of the first piece of the product, which is 5, plus, because we're multiplying it with another piece, log base 7 of the second piece of the product, so log base 7 of x, again plus, because we're multiplying here, log base 7 of the last piece of the product, which is y. So log base 7 of y. So we've expanded log base 7 of 5xy into 3 terms using the product property. Okay, so let's go back to our properties. The next one we want to talk about is the quotient property. Quotient means to divide. You can recognize that you should use the quotient property when you have log base something of a fraction or a division problem here. So this little division bar indicates that it's division and you're using the quotient property. If you are dividing two numbers, typically that makes numbers smaller. The other operation that makes things smaller is subtraction. So whenever you expand a quotient, a log base b of a quotient, then you give the numerator to the first log term, the denominator to the second log term, and you separate them with a subtraction sign because division and subtraction go together. So let's say I have log base b of 2/5. I would rewrite this with the same log base b, so log base b of the numerator, 2. And since this is division, I'm going to subtract in the expanded form the same log base b now of the denominator. So this is what the quotient property looks like. So I'm going to move to example 2 on the second page. Example 2, I recognize that I'm using the quotient property because I'm taking log base 5 of a fraction, so this is quotient property. When I expand log base 5 of 6/7, I'm going to take log base 5 of the numerator, and I'm going to subtract, because this is division, log base 5 of the denominator. So this should expand to be log base 5 of 6 minus log base 5 of 7. Okay, let's move back to our properties of logarithms. We have one more to talk about. The power property is exactly what it sounds like. It's a property involving powers or exponents. So when you have log base b of something raised to another power, the trick is to take that power and bring it out in front so that it becomes the new coefficient of the log term. So I'm going to show you why this works. So let's say that we have log base 4 of 3 squared. Well, would you agree that 3 squared is really 3 times itself 2 times? So I could rewrite this as log base 4 of 3 times 3, because that's what 3 squared is. And from product property, we know that if we're taking log with a base and a product, we can expand this to be log with the same base of the first piece of the product plus log with the same base of the second piece of the product. So I can rewrite this as log base 4 of the first piece of the product plus log base 4 of the second piece of the product. So I have log base 4 of 3 plus log base 4 of 3. Those are exactly the same terms. So how many log base 4s of 3 do I have? I've got 2 of them. It's like adding like terms, like x plus x equals 2x. So the shortcut, instead of going from here to expanding to this and combining like terms, instead of going through all that every time, the shortcut is just to take the exponent and bring it out in front. because that's how many of these log terms you're going to have. You're going to have this many of them. So let's practice for example 3. I can tell that this is going to be a power product problem, or power property problem, because I have x to the power of 3 here. So this is a power property. I'm going to rewrite this with the power, the exponent, as the coefficient of the log term. So this expands to be 3 log base 2 of x, not x cubed anymore because the 3 became the coefficient. How easy is that? So, the properties of logarithms, all 3 of them, can be used to expand or condense, which is the next day's topic, a logarithmic expression. Sometimes you'll use one property, sometimes 2, sometimes all 3 in the same problem. Expanding logarithmic expressions means to break down a single logarithm into the sum or difference of 2 or more logarithms. The trick is they need to have the same base. So it's almost like combining like terms. If you've got 2x squared plus 5x cubed, you can't add together the x squared and the x cubed terms because they don't have the same exponent. Same thing here. If they don't have the same base, they're not like terms, you can't put them together. So when you break things apart and expand, your logarithms are going to have the same base as the original expression. There is no multiplication or division left in the expression when it's expanded. So if you think you're done, you look at your problem, and if you've got multiplication or division left over, then you're not done. So let's go to example 4, the last one on the second page. We've got log base 3 of 4x squared y to the power of 5. There's no quotient here, there's no division, so I'm not using quotient property. I do see some exponents, that's the first thing I see, so I'll use power property. I also see that this thing that I'm taking log base 3 of, there's multiplication here, there's multiplication here. So not only am I using the power property, I'm also using the product property. So I'm going to use product property first. Product property states that if you have log base 3 of a product, then you can break it into log base 3 of each individual piece of the product and add the logs together. So I'm going to expand this to be log base 3 of the first piece of the product, 4, plus, because we're multiplying, log base 3 of the second part of the product, plus, because we're multiplying, log base 3 of the last part of the product. And I didn't mean to put parentheses around that, it just kind of happened, but it's okay. It's correct. So this, we used product property. Now we need to get rid of the exponents that you see here because remember there's no multiplication or division left in the expression when it's expanded. And x squared can be rewritten as x times x. And y to the power 5 can be written as y times itself 5 times. So we've got some multiplication here. We're not done. So now we're going to use power property. We're going to take any exponents that we see. There's none here. And I'm going to bring them out into the front, and they're going to become the coefficients of those terms. Not to the very front of the expression, but to the front of its term. So this is log base 3 of 4. That first term is unchanged. Plus 2 log base 3 of x. Plus 5 log base 3 of y. And we found this with power property. Notice that what I'm taking log base 3 of are no longer being multiplied or divided from each other. So 4 and x and y. There's no multiplication or division, so this is my final answer. So I'm going to move to the last page of the notes because each of those problems was relatively simple. The first 3 we only used one property on. Number 4 we used 2 properties on. The examples on the last page are a little more complicated just because they combine more of the properties. So the instructions say to expand each logarithmic expression using the properties of logarithms. Now there is an order to which you should use. So the order is you need to get everything out of a fraction first, so you need to apply the quotient property. After you apply the quotient property, you need to expand the product, so you want to use product property. And finally, at the end, you move those exponents to become the coefficients, so finally you use power property. So this is the order that you want to work in. It makes sense because you can't kind of split up this product and this product until you've split up the whole division problem that's here. So first I'm going to use quotient property. Quotient property states that if you have log base b of something over something, then you can split it up into log base b of the numerator minus log base b of the denominator. So I have log base 7 of 2x cubed y to the power of 8 minus, because this is division, log base 7 of 3 z to the power of 4. So this is quotient property. Now I want to use product property. I want to break up the products that I see here and here. So I'm going to break this up. There's a product of 2 times x cubed times y to the power of 8. So I'm going to break this up into log base 7 of 2 plus log base 7 of x cubed plus log base 7 of y to the power of 8. So that's my first term expanded a little bit more. Now I need to subtract the expansion of the second term. So I'm going to open up parentheses because I am subtracting everything that I expand this to be. Again, product property. Log base 7 of 3 plus log base 7 of z to the power of 4. This is product property. And finally, we want to use power property so that we can get those exponents out into the front of each term. So the 3 will come out in front, the 8 will come out in front, the 4 will come out in front. So I have log base 7 of 2 plus 3 log base 7 of x plus 8 log base 7 of y minus, and keep in mind here that I'm subtracting this set of terms, so I need to subtract this term and this term. I need to distribute that minus sign. So I'm going to subtract log base 7 of 3, and then I'm also going to subtract, the 4 comes out in front, 4 log base 7 of z. And this is the power property. So I've done my best to finish expanding. The logs that I'm taking are of 2 and x and y and 3 and z. Nothing in there is multiplied or divided, so I finished expanding. So what I'd like for you to do is pause your video and try number 6 using the same order that you see here: quotient property, product property, power property. You should probably have 3 lines of work, 1 for each property that you're using. So pause your video and try number 6. So number 6, I actually have 4 lines of work because I distributed my negative in a different and separate step. But first, when you use quotient property, you end up with log base 3 of x squared, the numerator, minus log base 3 of the denominator. When you apply product property, the first term doesn't change, but the second term becomes minus log base 3 of 4 plus log base 3 of y plus log base 3 of z to the power of 4, all the pieces of the product. I did distribute my negative here, so the only thing that's changed is the signs and the fact that there are no parentheses. And then finally, I used power property to take the 4 and move it in front, and the 2 and move it in front. Notice that x and 4 and y and z, what I'm taking log base 3 of, are they have no multiplication and they have no division in them. All right, so let's move on to 7 and 8. 7 and 8 are very similar. I'm going to help you with 7 and a little bit with 8, but I'm going to hope that you can finish 8 on your own. I do want to remind you of something, that when you have radical form of a term, so like if you have the ith root of x to the power of e. And I just chose I and e because I stands for index and e stands for exponent. So if I want to change this to not be under a radical, I would take the index and it would become my new denominator of the exponent. So this would be x to the power of e over I. So in example 7, this x really is to the power of 1. The square root has an invisible 2 here for the index. So if I wanted to rewrite this not as a square root, I would take the 2, bring it around, and it would become the denominator for that exponent. So this is really log base 9 of x to the power of 1 over 2 over y squared. And I'm saying that because now it works with our power property. I don't have any products that are happening. I just have division and I have powers. So those are the two properties that we're going to be using. So this should be log base 9 of x to the power of 1/2. Because this is division, I'm going to subtract log base 9 of the denominator, which is y squared. The only thing that we have remaining, since there's no products, is we need to take our exponents and make them the coefficients of our terms. So this is really 1/2 log base 9 of x minus 2 log base 9 of y. So keeping that in mind and realizing that you need to take this radical form and make it rational exponent form, you want to take your index, rewrite it as your new denominator of the exponent. So this is log, no base is shown, so it's implied that it's base 10. Just like if no index is shown, it's implied that it's an index of 2. So log base 10 of x to the power of 2 over 3 over y to the power of 5. So I'm going to help start you off, and then I'd like for you to pause your video and try the rest of this problem. Go ahead and check your answer. And this is how you would apply the quotient property, the product property, and the power property when expanding logarithmic expressions.